Good afternoon. My name is Scott Payne. This is my Math 502 final exam presentation, video 1. Let's go ahead and begin. So this first part is going to be an example of a pivot or pivotal quantity. So let's look at, we're going to be looking at example 9.28 and 9.29. So let's keep going. All right, first of all, 9.28 kind of starts off with a problem. So let's kind of go through that and kind of set the stage, if you will, and kind of what this is going to be kind of covering. So suppose that we have x1 to xn. So we have an IID, independent, independent. Good afternoon. My name is Scott Payne. This is my Math 502 final exam presentation. It's video 1 of 3. So let's go ahead and get started. This first one is going to be an example of a pivot or pivotal quantity. We'll be looking at example 9.28 and 9.29. Both of those are kind of linked together, so we'll kind of treat them as one. So let's start off kind of with the problem statement itself and kind of what are we trying to accomplish here. First of all, it says suppose x1 to xn are IID. That's independently and identically distributed. We have an exponential, lambda, and asked to really construct a confidence set. That's kind of 2.9. But that's a two-step process. First is, does the pivot exist, and well, what is it? Let's kind of start there. And then 2, we'll construct the confidence set. And that's kind of broken down, I guess, into kind of an A and B, or at least the way I think about it. So if your Q is a pivot, that's going to be our pivot variable here, then for a specified value of alpha, we can find numbers A and B, kind of boundaries, if you will, which do not depend on theta to satisfy the probability that's given here. So we have the probability given theta that this Q, that this pivot is greater than or equal to A, less than or equal to B, and that probability overall is less than 1 minus alpha. That's where we kind of get our confidence interval. And then part B, for each theta, so for each parameter within a set, we're going to look at an acceptance region, kind of governed by this, for a level alpha test of the null hypothesis. So let's move on and kind of get kind of where we're going. So step 1, does a pivot exist and what is the pivot? Well, we start out in this problem kind of with an exponential PDF, f of t given lambda. So we have our exponential distribution here for t. Here's our bounds here, greater than 0, less than infinity. Now, since the PDF has a form, 1 over sigma f of x over sigma, it is a scale family. Okay, and we get that from Cassell and Berger. Therefore, it is a pivotal quantity, right, that now I can write as x bar over sigma, which really means Q can be written as the summation of all xi divided by our lambda. Okay. Now, with so if I take my statistic, I set equal to the summation of x sub I, and therefore what that results in is then I can say that this pivot is really just t over lambda, okay? So I'm just substituting in t summation of x sub I in for this numerator, and that just gives me that my pivot, is just t over lambda. Now, since we know that a gamma distribution has the form as follows here, and I've written this out here, f of t given that n in lambda, so this is a gamma distribution, okay, of that form. And I'll put a little asterisk here and draw an arrow. We're going to pay specific attention to this minus t over lambda or just the t over lambda part. If I let this pivot be 2 times that t over lambda, right? And then rearranging it, I can write that as 2 over lambda times t. Now, what that's going to allow me to do is that now this pivot follows this distribution, gamma, n. Now, really what I can do is I can replace, I got this lambda, I can multiply by 2 over lambda, right? And 2 over lambda is going to come from this pivot, and then I now can have a gamma distribution n comma 2. Now you may say, well, why is that relevant? Why does that even matter? is that, but the gamma n2 is nothing more than a chi-squared distribution, okay? So therefore, what can we say? We can say that our pivot is 2t over lambda with a gamma distribution, okay? So we've really eliminated the lambda out of that process. Now, step 2, once we've gotten that part out of the way, is really to conduct the confidence set. So we have a sample, x1 to xn. We've defined t as the summation of x sub I, and our pivot is 2t over lambda, which we said follows a chi-squared distribution. Now, what we want to do is we want to choose constants a and b to satisfy what we previously said kind of in step 2, part A, is that I'm looking for a probability now that my chi-squared is greater than or equal to a, less than or equal to b, and that overall probability is less than 1. So we can move really, if you think about it here, from left to right. I've got probability based on lambda, then I've got a probability based on lambda, but now with the with my Q, okay, my pivot, which then leads me to say, well, hey, I've got a probability with this chi-squared being greater than or equal to a, less than or b equal to b, and that's equal to 1 minus alpha. All right. So the next, though, we need to invert. So now step 2, part B, on the first part of the actual analysis, we have an acceptance interval where it's the set t, where we got 2t over lambda greater than or equal to a, less than or equal to b. That's going to give me now my confidence set, C, where then I'm really just solving for this lambda and this inequality here. So I'm doing that. That's going to flip signs here. We've got to flip the inequality. So our B becomes our lower bound, and then the A part over here becomes our upper bound. Now, noting that N is equal to P over 2. Now, P is the degrees of freedom here. So if we use an example, as the book does, of 10, that's going to produce a 20 degrees of freedom, right? Well, if you look up a chi-squared distribution with 20 degrees of freedom and a 95% confidence interval, you're going to be between the values of 2t over this 34.17 and 2t over 9.59. And that's really how you set up your confidence interval. Okay. All right. And that's it. Well, thank you so much, and I'll see you in video 2. Take care. Bye-bye.